Hello, everybody. It's actually a very exciting moment for me because I'm going to be talking about workshop. The product I've been working together with some other Canonical engineers for quite a while now, and it's the time for this product to see the light, to see the rest of the world. As Mark mentioned today, it's going to be one of the ways we suggest for developers to organize their development environments, and especially in the agentic era. So as mentioned, we started to work on this before agents came on board, and it surprisingly turned out to be fit for those agents. But I'll start with a problem space. So I wanted to define the problem space first and why we actually started to work on this. So we start with something that's like an error-prone setup, an AI, ML area, or some other complex development environments that require you to run and maintain your components in that environment and then sync with the rest of the team. So it's always getting out of hand. Something goes unupdated, something breaks on the host system, and it was obvious for us at the time that we should actually look at the containers. And at the time, Canonical already had a pretty good piece of tech, which is LXD. So that's where we started the exploration from. That's where it all comes from. So when AI agents arrived, it turned out to be that for them, isolation also makes sense. And actually, you want to be a little bit more disciplined about how AI agents run in those containers. That's why we came up with something that we now call workshop. And workshop is a development environment that runs in the container. Well, in our case, it's a LXD container at the moment. And there are three things that I'd like to highlight about workshops that I think are important. And I'll be elaborating more on all three. So workshop is a composable, secure, and fast development environment. So what do we exactly mean by composability? So as mentioned, workshop is a LXD container. So when it runs, we need a mean to create this container from the ground up. The workshop container can be created with something we call SDKs. So SDKs are just individual pieces, individual components that are responsible for installing a piece of development environment or a part of development environment. In that case, you can see a workshop container running with Jupyter, ComfyUI, and ROCm SDK. So system SDK is something we install in every workshop container by default, and it's just responsible for interacting between the host and the container. By composing SDKs together, you can arrive at the workshop definition that will describe your development environment in this container. So I'll briefly stop on what the SDK is. I'll have a separate section about the SDKs, and I'll talk a little bit about SDKs in more details as we go. But for now, SDKs consist of four parts. It's the metadata, interfaces. Interfaces is our approach to expressing the intent for an SDK to use a certain resource or provide a certain resource. Hooks, these are basically scripts, and the content itself. SDKs themselves, they come from the SDK store. This is the counterpart of the Snap store. The SDKs are being published by the publisher. And through the channel semantics, they can arrive into the workshops and then build this workshop environment from scratch. As you can see, there are all sorts of variations and runtimes that we host as reference SDKs in the SDK store. So it's the tool chains, agent environments, ML/AI frameworks, RTOS, ROS2, you name it. Now let's talk a little bit about security. So secure, when we say it's secure, we mean that we have a very limited access to the host resources from within the workshop. We implement that through the mentioned interface system, and in the beginning, workshop starts as an unprivileged LXD container. So when LXD gets the SDK installed in it, when the LXD container gets it installed, the SDK can request a certain resource. Like in this case, it's a desktop socket or SSH engine to be available in that container. And as per the policies that we define for every interface type, workshop can decide to either allow or disallow access to this resource automatically and require a manual connection from the end user. And a few words on the sandboxing as well. So we imagine that working in the same fashion. So you can use the workshop to run agent environments and then agent workflows. So this example is the UV, Go, and Open Agent SDK running in the container. So when Open Agent runs in the container and needs a certain resource, it can actually request it from the user, and then it's on the user whether to expose GPU, NPU, desktop, or anything else that's exposable in the container or not. And then to the third point that I mentioned, it's the what we mean when we say fast. So we mean a few things when we say it's fast. But mainly, it's about how we use ZFS snapshots and clones to operate workshops. So imagine this. This is a workshop running with 3 SDKs, System, CUDA, and Llama. Every time an SDK gets installed in a workshop, we make a snapshot. And then eventually, we have a final workshop running with CUDA and Llama in the same container of that ZFS snapshot. Now, we need to run a second workshop, and that second workshop only uses the CUDA snapshot. But given that we already have the same stack of snapshots for this environment in the system, we restore the workshop from the ZFS snapshot and run it almost instantly. So that is important for how we intend the workshop to be used, because every project may have multiple workshops depending on your branches, depending on the variations of the dev stack that you run. And we want them to be first, well, easily launchable and refreshable, so you can operate them faster, and also space optimized, because some of these SDKs, they are pretty heavy in terms of the disk usage, so we want to optimize that with ZFS snapshots. Now onto the actual experience. So I wanted to pause that here a little bit and discuss how we imagine that to be working. So workshop definition is a file that's called a workshop YAML. It is usually in the source tree of the project. When you clone it, workshop launch, and that gets you the working environment. So that has SDKs installed, interface connected, and your project directory mounted into the workshop container. So from there, regardless of the complexity of the dev stack, regardless of what needs to go into that final container, we're done with getting the working environment up and running. Let's look into the definition. So as I mentioned, workshop definition is a YAML. We'll design it right now. We just unfold it in terms of what comes into the workshop definition here. So we'll start with the name and the base. Can be any of the latest LTS bases. We'll add one SDK, that's the open code I mentioned before. ROCm SDK here as well to get access to the GPU. And then Go SDK just is an example. So as you can see, the ROCm SDK comes from the specific version channel. It's going to install ROCm from 7.1 on 2404. I'll get to the demo. So I'll talk as it goes, but what we want to demonstrate here is how actually workshop is going to run. So it's let's look at the definition that we just built. Open code is one of the SDKs. We gotta look into the open code information that's coming from the store. So all these SDKs, they come from the store from various channels. But open code, it is coming from the latest table, supporting all the bases of this current version. And then there's some metadata in it as well. So we have a workshop definition ready. Now let's launch it. Currently it's off. It means that workshop definition exists in the project directory, but the workshop itself is not running. So when we launch, workshop will download the SDKs, install them into container, run hooks, enable interfaces, and get the environment working. So that's pretty much it. Demo is ready. Now we just confirm this. We can shell into the workshop and see this /project directory is available from within the workshop. GPU is also available because we requested it in ROCm. And we'll just do something interesting. And actually, if you continue exploring that with open code, it gives you lots of interesting stuff. When you ask it about where you run, try to break out of this container and things like that. So it's a Linux container, obviously, but if you explore, it'll give you more and more details. And eventually, we'll come across things like interfaces. We'll guide you through how to connect these interfaces to a workshop. So that was launch. So launch is the first most important command to get the workshop environment up and running. Now it's on to do refresh. So we want workshops to be updatable in the sense that when an SDK or anything actually in the definition changes, we want to be having an incremental update to that workshop in place rather than relaunching it from scratch. So in this case, let's have a look at ROCm. It's currently coming from 7.1 stable in the previous example. So now I have updated it to 7.2/stable. When we run refresh, what we're gonna do here is to fetch the new ROCm version from 7.2 stable, restore this workshop from this snapshot. As I mentioned before, we use RFS snapshots, so it's going to be much faster than creating it from scratch. Install ROCm, install Go, connect interfaces, and what's also important, restore the SDK state. So in that case, as every SDK defines the state, how it actually wills. But in our example, it could be open code sessions. It can be credentials and things like that. It's not always rainbows and unicorns, and sometimes the things go wrong with refresh. That's the way we look at that with workshop is we need to have two different modes for every command. So first is the transactional mode, and you can see that here on the screen. So for example, if you updated your workshop definition, so what refresh tries to do in a nutshell is just tries to take this updated definition and match the running container to that definition. If it fails to do so, it just rolls back to the previously working version of the workshop. So in this case, update to 7.2 failed, and workshop just aborted the run and restored the previously running container. A second mode for this kind of commands for refresh and launch is for debugging. So if something goes wrong, what we allow to do is to refresh or launch the workshop with wait on error mode, which will pause the execution right at the moment where the error happened, and allowing you to shell into the container, debug something that's not happening, wrong package name, wrong scripts configuration, and stuff like that. And then continue the refresh or abort the refresh in a similar fashion. How will you do with failing rebase? It's -- continue, -- abort. Okay, so that's about two major workshop commands. Basically, you operate them workshops with only these two commands: workshop launch and workshop refresh. I wanted to dive a little bit deeper into the SDKs, what they actually are. So as mentioned, they're composed of four different parts. First is the meta. Meta defines the base, the name, the architecture, license, other fields that are important for the store and for consumers. The interfaces. So the interface system in workshops is the exact interface system that we have in snaps. only it was adopted for the workshop scenario, and it is used to uniformly, and in my opinion, more disciplined way to provide a resource into the container when an SDK needs it. For example, we have a ROCm SDK, and it declares that it needs a GPU exposed into the container. A system SDK acting on behalf of your system or on the host system exposes this GPU as a slot. So a pair of plug and a slot, it needs to be connected for this resource to become available in the container. So when we do this, the GPU becomes available in the container. So it means that when SDK declares something that it needs in the container, it declares a plug. That's how it's consuming the resource. And when the SDK declares a slot, it means that it provides this resource. So in this case, it's the GPU, but it can be byte mount or anything like that. So this same language, this same way of having the resources from the host or from other SDKs shared with this container is applicable to all sorts of other interfaces. We support GPUs, mounts, tunnels, desktop agents, camera, custom device, and other things. Then it's hook. So SDK itself is not just a dead blob there. It's coming from a few hooks in most cases, and these hooks allow the SDK to execute custom logic in the runtime when Workshop is getting launched. So this case is when we launch it. So it's going to be coming through a series of hooks where SDKs get a chance to do something to the container, to the environment that they run in. It starts with the setup base, which runs after you have a base image and container running, but no interface is connected. Nothing else is exposed into the container, so it's a chance to set up the base. Then it's set up project, which means project-specific logic when /project is mounted already, when the interface is connected, and we can do something more interesting. And then it's a lightweight check of health, whether this SDK approves its own installation in the workshop, and if it's not, Workshop will execute the automatic rollback that I mentioned before. And then it's the content, binaries, systemd units, services, configurations, anything that SDK decides to bear and install in the container comes as content. All right, let's look in the interfaces. So we have a running workshop already from the previous demo. It's the workshop with the ROCm installed. You can see here, it's like 7.2. So what we're gonna do is we want to shut down the access to GPUs in this container. So we have a few connections running right now. What we're gonna do is to ensure that, of course, GPU is available. And now we're gonna pull the plug and disconnect the GPU from the container. So no device anymore. So that's this basic principle of how interfaces work and how you can describe relationships between your SDK and what the SDK needs in this container. And the third important part, third pillar to this product, after we've talked a little bit about workshops, we talked a little bit about SDKs, and now where the SDKs come from to compose a work environment. And that's the SDK store. So I'll start with the other angle, other side of the experience of someone who builds an SDK. So I mentioned that it could be any sort of runtime, any sort of toolchain, things like ROCm, OpenVINA, some hardware SDKs. And these are SDKs that are designed and built by publishers, so they know best how to install this particular SDK into running container. They do it while we do, they define it while they design the SDKs for a workshop. And this is the simple workflow. So you start with some boilerplate. SDKs are testable components. You can define tests, run them in the CI/CD to ensure that still working with the latest workshop updates, with the combinations of SDKs, things like that. Once you're happy, you pack and release to the appropriate channel in the store. The store itself, the experience of discovering an SDK and using it in your project is in CLI. We have an SDK command that's called SDK. So here we discover a couple of SDKs. We can look through the available ones in the store, and once we settled on what we actually want, workshop init to create you a basic workshop from the SDK set, and then workshop launch again to get the working environment up and running. I wanted to talk a little bit about channels here because I think it's important how we deliver this SDKs to the target users, to the workshops. So in this example, we defined a very simple workshop that runs a Node SDK, and it consumes the Node SDK from the channel that's called 24/stable. So that means 24th version of Node LTS. But it's not as straightforward underneath, because it can be different architecture, different base, different LTS revisions. So for Node specifically, it can be 20, 22, 24, and so on, 26 soon to be. So in this particular case, when we launch a workshop, we consume this SDK from this particular channel from a stable risk for the base that is 2404 and for AMD 64 architecture. So that's all resolved automatically when you workshop launch. Workshop will talk to the store, find the appropriate artifact, and install it transparently into the workshop without you taking much care about this. Let's reiterate. So workshops are composable, secure, and fast development environments, and they are launchable in a single command. So that's the major workshop promise. Whatever your environment is, however complex that is, we want it to be launchable on a single command. And SDKs are the testable and independent components that go into the workshop. So however complex the environment is, we still want it to be expressible through a series of SDKs and immutable in the corresponding repository for this project. This is how we start exploring the workshop. So it's basically snap install. We have a collection of reference SDKs. It's about 20 of them. So it's the SDKs from vendors like Intel, AMD, and NVIDIA. So tools like ROCm, CUDA, OpenVINA can be installed as SDKs and work in this confined environment. Of course, agents SDKs for the most popular agents too. Various tool chains, UV, Flutter, Go, etc. And some very specialized SDKs we found suit our use case very well. These are the RTOS environments and robotic operating system environments too. Everything is available as an SDK and can be installed in the workshop. And then there is the documentation that talks about the commands, the concepts that I've just explained, and more. Thank you.